Okay, so determining quadrants of angles. So section 7.3, I think I actually put it on the next slide. The directions are, without a calculator or a table, determine if the value of the given trig function with angle measure is positive, negative, or zero. Why are the quadrants important? The quadrants are exactly what tells us which trig function is positive or negative. And I've talked about this before, but reiterating doesn't hurt. First quadrant, no matter what we're talking about, our x coordinate is positive, as is our y. In the second quadrant, x coordinate negative, y coordinate positive. Third quadrant, both x and y are negative. Fourth quadrant, x is positive, y is negative. Okay, the importance for this for trig, when we're working with the unit circle, so here we are again. Unit circle, that's our circle with a radius of 1. That gives us the values of sine, cosine, and tangent of angle measures. Your x coordinate always refers to the cosine value of your angle measure. Your y coordinate always gives you the sine of your angle measure, as long as you're on the unit circle, okay? Otherwise, we have to use the fact that x squared plus y squared equals r squared. And that's what we've done in the previous video. So when I look at my first quadrant, if both my x and my y value are positive, then if an angle's in the first quadrant, cosine and sine, oh, my screen doesn't work over there. Sine and cosine are both greater than 0. Okay, so in the first quadrant, cosine is positive because cosine is the x-coordinate. Sine is also positive because sine is the y-coordinate. And I've done this on the homework. This is just to reiterate it if you need more help. In the second quadrant, all your x-coordinates are negative, all your y-coordinates are positive. So in the second quadrant, your cosine's negative, but your sine remains positive. In the fourth quadrant, both x and y are negative. So cosine is negative as well as sine. In your fourth quadrant, x is positive, y is negative. So in the fourth quadrant, your cosine is positive, but your sine value remains negative. Okay, I'm going to skip ahead because we're going to talk about this in a second. But so sine, cosine, and tangent. That's not what I wanted to do. Okay. Your tangent function is the ratio of your y coordinate to your x coordinate. So if I think about this in terms of sine and cosine, my tangent function, my y is my sine, is the sine value divided by the cosine value. I get into this in detail in the next video for lesson 7.4, but I just want to bring it all in here. So if tangent is y divided by x, then when in the first quadrant, if I take my y coordinate and divide it by my x coordinate, it's going to remain positive. So my tangent's going to be positive in the first quadrant. In the second quadrant, a positive y divided by a negative x will make my tangent value negative. In the third quadrant, a negative y divided by a negative x will make my tangent value positive. And then in the fourth quadrant, my negative y divided by my positive x, it'll keep tangent negative as well. So I refer to this a lot, and I might as well introduce it now. Again, it doesn't hurt. A, S, T, C. So what do these letters represent? These letters represent which trig functions are positive in the given quadrants. So A means all my trig functions, right? Sine, cosine, and tangent are all positive in the first quadrant because x and y are both positive. So the S in the second quadrant, that tells me that only my sine function is positive in quadrant 2. The T in the third quadrant, hold on, honey. Sorry about that. Maggie's ready to clean the house today. The T stands for my tangent function is positive in the third quadrant. And then lastly, the C tells me that my cosine function is the only positive trig function in the fourth quadrant. So we'll be using that a lot. And I know I sound like a broken record, but the reiteration is good for you. Determine the quadrant for each. Okay, this is the first video I asked you to watch on the relationship between top, bottom, quadrants and where all of that sort of makes sense. So I'm going to highlight a few things first. Pi over 6, pi over 4, and pi over 3 is not up here. These are what we call our reference angles. So notice here that when the coefficient to pi is a 1, first quadrant. So on your homework, it'll say like, is the sine of pi over 4 positive, negative, or 0? So you got to say, oh, well, pi over 4 is in the first quadrant. In the first quadrant, my sine function is positive. It's not asking you for the value. It's asking you for the sign of the value, meaning is it a positive number, is it a negative number, or would it be 0? Okay, 7 pi over 6. So to determine the quadrant, what's your relationship between your top number and your bottom number? My top number is my bottom number plus 1. What do I mean by that? My top number, my coefficient of 7, is 1 more than the value in the bottom. Okay, so when this relationship is true, this is a third quadrant angle. So depending on whether the homework asks you for the sine or cosine of that, will tell you if it's positive or negative. All right, 3 pi over 4, when I look at this, my top number, is my bottom number minus 1. What do you mean, Mrs. Foreman? My top number of 3 is 1 less than my bottom number. So that tells me 3 pi over 4 is a second quadrant angle. It's all about that relationship. Okay, here my top number is my bottom number plus 1. So that's going to be a third quadrant angle. 4 pi. All right, well, 4 pi doesn't have a denominator. So let's think about where we are on the unit circle. All right, 4 pi, it doesn't have a denominator. Don't freak out. Let's think about where we are on the unit circle. Here's 0. Half a rotation gets me to pi. Another half of a rotation gets me to 2 pi. So let me keep going. 3 pi, 4 pi. So 4 pi is on one of the coordinate axes. The coordinate axes have specific values. So at this point, so 2 pi and 4 pi are at the same spot. Well, depending on what the question asks, whether the cosine or sine, this is either going to be a positive or a 0. Okay, pi over 2. All right, so when I look at this, all right, pi over 2. Oh, man. So pi over 2 has a numerator of 1. And when I look at this, I say, okay, my top number is bottom number minus 1. Sweet, I'm in the second quadrant. Nose goes. The only time the relationship works is when your denominator is a 6, a 4, or a 3. And the importance of reference angles, again, come in next lesson, but it's good for you to hear it a few times. So, no good. Why? Well, you got to think back to your unit circle. Where's pi over 2? Pi over 2 is up here at 90 degrees. Coordinate axes have ordered pairs because they're on the unit circle. So whether I'm asking you for the sine or cosine, you got to look at the ordered pair to be able to answer that question. 3 pi over 2. There's my denominator of 2 again. It is not in a quadrant. 3 pi over 2 is down here at 270 degrees. The ordered pair is 0, negative 1. So I have to be aware of what trig function I'm asking you for. Okay, pi's over here at 180 degrees. So again, no quadrant. When I look at 5 pi over 6, my top number is my bottom number minus 1. That puts me in quadrant 2. 11 pi over 6. All right, well, my top number is not my bottom number plus 1. But my top number is twice my bottom minus 1. So this relationship here puts me in quadrant 4. Okay, 5 pi over 4, my top number is my bottom number plus 1. So this puts me in quadrant 3. All right, this is taking a little longer than I had anticipated, but these 3 relationships tell you your quadrants, but they only work when your denominator is a 6, a 4, or a 3. Okay, let's go to negative angle measures. So when we measure angles, we start at 0 here. And when theta is positive, we rotate in a counterclockwise direction. So when theta is negative, we rotate just in the clockwise direction. So if I want to know where negative pi over 6 is, I always start here. And you got to think pi over 6, from here, I would be rotating, it'd be a first quadrant rotation, but in the opposite direction. So from start, I'd rotate and I'd land about there. So I'd be in quadrant 4. Negative 7 pi over 6. Well, 7 pi over 6 is a third quadrant rotation. So from start, here, 1 quadrant, 2 quadrants, so I'd land in a third quadrant rotation. Well, when I'm talking about whether my trig functions are positive or negative, though, that negative rotation, that clockwise rotation, puts me in the second quadrant there. All right, when I look at 4 pi over 3, that's another third quadrant rotation. So if I rotate from start in a clockwise direction, I'm in quadrant 2. Negative pi over 3, well, pi over 3 is a first quadrant rotation. So if from start I go in a clockwise direction, I'd be in quadrant 4. Negative 3 pi, so here I am at start. Now half a rotation, that would put me at negative pi. Negative 2 pi would put me back to start. So negative 3 pi would put me back at pi. So here we are, these don't have quadrants. This is on a coordinate axis and it's at the same spot as pi. So the ordered pairs for pi are negative 1, 0. So depending on if you're answering the question, am I positive, negative, or 0? Okay, 5 pi over 6 is a second quadrant rotation. So I'll change my highlighter color. From start, I go through 1 quadrant and I end in my second quadrant, but I'm doing it in the clockwise direction. So I would land in quadrant 3. All right, I'm running out of time here. My kids are banging on the door. So I want you to try these. Negative, and check them. So pause the video, try and determine where these angle measures are, and then check your work. Okay, so check those, and then let's talk about the pi over 2. So pi over 2 should be, all right, I know I'm on a coordinate axis, and I'm either going to be up at pi over 2 or down at 3 pi over 2. But we're going in the opposite direction. So here I am at start. There's negative pi over 2, negative 3 pi over 2. So negative 5 pi over 2 would put me back down here. So what I hope you're seeing is that they repeat. They're periodic functions. So if I know one rotation from 0 to 2 pi, I literally know every single rotation that I need. So if I'm going negative 3 pi over 2, that means I'm just going 3 pi over 2, but in a clockwise direction. So here's negative pi over 2. So negative 3 pi over 2 would put me up here. Well, if I'm talking about the values, well then let me write it in terms of an angle measure I know. So negative 3 pi over 2 is at the same spot as pi over 2. Then from here, these have ordered pairs that will tell me whether the sine or cosine function is positive or negative. Okay, I think degree measures are the easiest, and I need you to make them the easiest for yourself also. So if I know what my angle measures are, I'm going to write these answers, pause the video, and see if you get the quadrants right. And then that'll be it for this video.